Hello everyone. I hope your test went well and I hope everything was good. Since I do have your undivided attention, I would like to just make sure that you guys did turn in a scratch sheet of paper with your name on it with all of the work shown on that test that you guys were given today. So please make sure that you did turn in a sheet of paper with your name on it that shows all of the work that you had to do for each of your problems. And I kind of hope that you numbered them too, because that'll help me when I grade, just to see your thought process. That's an important part for me. So anyway, I do thank you guys for being patient. Just understand that my daughter broke her arm and I'm home with her and she's recovering and everything's going well. So, but anyway, let's get started here. So this is the worksheet that you probably picked up in class right after your test. And what I'm going to do first is I'm going to begin with a very short lecture just to remind you how to do these problems. I know you've seen them before. We had a warm-up that was very similar to this. So I'm pretty confident that you're going to do just fine on this, okay? So let's take a look at the lecture first. Get your notes ready and get a periodic table and a calculator. All right, so just pretend like these are your notes, and you should be just writing these down into your notebook, okay? So we're going to take a look at a small little sample here. So let's pretend that you have 14.2 grams of sodium and 12.9 grams of sulfur, and I ask you which one is the limiting reagent, what is the maximum amount of grams of sodium sulfide that you can make. And I want you to pause this video and really try to think your way through the problem before I show you how to do it. So you're starting with mass. You have two masses, notice in this problem, you have two different masses. So I hope you know that you're going to be setting up two different stoichiometry problems. And I think you can anticipate, just like we did before, the answer that produces the lesser amount, that will be the maximum amount of sodium sulfide that you can make. So give yourself a minute before you proceed. You may want to hit pause. Okay, so you'll notice that you have two different problems being set up. And just like a traditional stoichiometry problem, whenever you start with mass, you need to know that the heart and soul of stoichiometry comes from these mole ratios from the balanced reaction. So if you are starting with mass, you have to convert the mass to moles so that you can get that mole-mole ratio in there. Notice that we're always cross-canceling. So if I started with grams of sodium, I'll convert that grams of sodium to moles and get that mole-mole ratio from the balanced reaction. And then they want to know the maximum amount of sodium sulfide that you can make. So at the very end, you'll notice that instead of just ending on moles of sodium sulfide, that I'm converting those moles into mass. So you see how everything flows, everything cross-cancels here. So that the only thing left that is not crossed off, that isn't cross-canceled, is grams of sodium sulfide. All right, so take your calculator, give yourself a moment, and let's see what answer you get. All right, so you see how you have two different values. The problem on the top gave you 24.1 grams, and the problem on the bottom gave you 31.4 grams. So the lesser amount, the one on the top here, is going to be the maximum amount that you can make. And the reason why is because the 14.2 grams of sodium limited the maximum amount that you can make. Therefore, we're going to call sodium your limiting reagent or limiting reactant, and therefore the maximum amount that you can make would be the 24.1 grams. Now what that means is that the 12.9 grams of sulfur, we used some of it, but there is still a little bit of sulfur that is not fully reacted left over when the reaction stops. This sodium, the 14.2 grams of sodium, is completely gone. All right, so if we were to look at whatever's left in the container, we'll have a little bit of sodium left over, and we will have 24.1 grams of sodium sulfide. So we're going to continue this question just a little bit further and dive in and ask ourselves, you know, how much excess of the sulfur do we actually have left over? So we didn't use all of the sulfur to make the sodium sulfide. We only used some of it. So how do we figure out exactly how much of the sulfur is left over? So how much of the 12.9 grams of sodium sulfide did it take to actually let's see, how much of the 12.9 grams of sodium sulfide did you actually, no, that's not what I meant to say. How much of the 12.9 grams of sulfur, sorry, did you actually use? And how much is still left over? So that's the question that you should be running in your head. So now what we are going to do is we're going to start a third problem. What I typically do is I take the maximum amount that could have been made of the sodium sulfide and I work from the sodium sulfide back to the excess reactant, the sulfur. So what we're going to do is, if you look back at your notes, take the maximum amount of sodium sulfide that you made and work a problem backwards to the sulfur. So the maximum amount of sodium sulfide that we could make was the lesser amount, the 24.1 grams. And I want to know, how much sulfur did it take to make that maximum amount? Because it didn't take all of the sulfur, it only took some of it. So we're going to figure out exactly how much sulfur it took to make that 24.1 grams. So you're going to work a problem with starting with the Na2S, and we want to end with grams of sulfur so that we can figure out exactly how much sulfur we actually needed. So as you can see, I just worked a problem starting with the sodium sulfide and ending with grams of sulfur. Now, this answer that you got tells you the amount of sulfur that you needed to make this product here, okay? So we originally had 24.1 grams of sulfur available to us, but we only used 9.91 grams of it. So how can we figure out exactly how much unreacted sulfur is left over unreacted? If this is the amount that was available to you, but we only used 9.91 grams of it, all you have to do is just subtract those two values. So you would just subtract these two values and you would get 14.19 grams of sulfur, and that is the amount that is left over at the end of the reaction when it stops. All right, there's a couple other formulas that I do want to remind you about. So in the worksheet, there's a couple formulas you're going to need. Something called percent yield. Percent yield is a very basic formula. It just is basically what was actually gotten in the lab, the quantity or mass that you achieved in the lab. So we're going to say actual over what you should have got, which is what we call theoretical, and then times that value by 100, and that's your percent yield. So theoretical is always found by doing some kind of math. So the theoretical amount requires math to be done, and the actual would have to be given to you like in the lab or maybe in the problem itself. So this quantity is achieved in the lab, or it's obviously going to be given in the problem. Okay, they have to tell you that amount. All right, one more formula I want to remind you of is, and you've seen this like a gazillion times, but I'm going to show it to you again. That would be percent error. Percent error is found by doing the quantity on the numerator. Make sure that you do like use parentheses on the numerator. What this is you're going to take the actual minus your experimental over, oh wait, I'm sorry, actual minus theoretical. Sorry, I didn't want to say that because the actual is sometimes called the experimental. Sorry, it's actual minus theoretical over your theoretical again, and then times it by 100. All right, so again, the actual is achieved in the laboratory. The theoretical will be determined through math. Okay. Sometimes the maximum amount that you can make, like that we calculated in this last problem, like the max you can make is sometimes called your theoretical, okay? So the theoretical is determined by math, and it's typically your maximum amount that you can make. Max you can make. All right, that should be enough to get us started on the worksheet. I'm going to do that first problem with you on the worksheet, okay? So grab it and let's take a look. All right, so it looks like on the first problem, it wants you to calculate the mass of alumina produced when you have 100 grams of aluminum burning in 100 grams of oxygen. And then it says, what is the limiting reagent? So it looks like aluminum is burning in the presence of oxygen, and you have to figure out what the balanced reaction is. Obviously, we can't do any stoichiometry without looking at the balanced reaction. So it looks like you have pure aluminum burning in the presence of oxygen. This is actually an oxidation reaction. Aluminum is a pure metal, so just, Al. And oxygen is a gas, so that would be like O2. And it looks like these two are combining to make this guy, aluminum oxide. All right, so this is the basic reaction. And first thing we got to do is to balance it. On the left, you have 2 oxygens, and on the right, you have 3. So try to think of a common multiplier between those two. And it looks like we're going to try to get 6 oxygens on both sides. So to get 6 oxygens on the left, I'm going to put a 3 right here. To get 6 oxygens on the right, looks like I'm going to have to put a 2 in front of the whole thing. Okay, and that gives us 4 aluminums. So I'm going to have to put a 4 over here. All right, now that we have the balanced reaction, let's take a look at the problem again and see what was given to us. You have 100 grams of aluminum and 100 grams of oxygen, and they want to know what is the maximum amount of aluminum oxide that you can get. So notice that they give you 2 quantities. Whenever you're given like 2 masses like this, that's kind of an indication that you're going to be doing a limiting reagent problem, and you'll need to set up 2 different problems. So we'll start with 100 grams of aluminum, and then we'll do another problem where we start with 100 grams of the oxygen. And we're going to work both of these problems to figure out the maximum amount of aluminum oxide that we can make. So we're going to end with grams of aluminum oxide. All right, pause the video. You know how to do this. Let's see if you guys can build the problem correctly. All right, so take a look at what I did here. Always get rid of the mass and change the mass to moles. Make sure you're doing the mole-mole ratio correctly. So I always have to label what I have in the problem in order to make sure that I'm cross-canceling. So if I've got moles of aluminum, I need to make sure that I have aluminum down on the bottom to cross-cancel that. And in this particular mole ratio right here, since I started with aluminum, I put aluminum to cross-cancel on the bottom with the 4. That's where that 4 came from. And I was going to aluminum oxide, so that's from the balanced reaction, and so I put the 2 aluminum oxide on the top. Okay. All right, so you have 2 answers. Which one is the maximum amount that you can make? That would be the 189 grams. That's a maximum amount you can make. You see how it's the lesser of these 2 values? So the lesser of the 2 values is the max you can make. This is sometimes called your theoretical yield. So I'll just symbolize that as Ty. And it wants to know, what is the limiting reactant? So whatever reactant produced the lesser amount is going to be your limiting reactant. So you see how the theoretical yield came from this first problem with the aluminum? Therefore, your aluminum is your limiting reactant, Lr. I'll just symbolize that, okay? So the aluminum is completely gone. All right, and that's all the question asked, so technically that would be your answer. So the maximum you can make in this problem would be 189 grams of aluminum oxide, and the limiting reactant would be aluminum. All right, this should be enough to take you guys through the rest of this worksheet. Best of luck. We will be reviewing this when I come back next week, okay? Thanks so much, guys. Bye-bye.